Hi everyone, and welcome back. In this lecture, we're going to look at a few other essential topics and some information relating to our data frames in Pandas. We'll cover a topic known as conditional selection, and then how to add and drop columns from our data frame, and then finish off by looking at how to drop rows as well. Let's go ahead and move on over into Jupyter Notebook and get started. Okay, so here we are inside of our notebook file. Continuing on from where we left off in the last lecture, we'll use our data frame containing some information on different people with their names, their age, and the city that they live in. Let's go ahead and talk about an important topic in Pandas, which is conditional selection. Conditional selection in Pandas allows us to filter rows based on specific conditions, and the way that we do this will be with square bracket notation. So very similar to when we looked at Boolean indexing and Boolean masks in NumPy. For our example, if we take our data frame here and say that where our age column is greater than or equal to 30, this will return a Boolean series where it returns true if the age was greater than or equal to 30 and false if it was less than 30. And this is very similar to our Boolean indexing that we looked at in NumPy. For another example, let's say that we want to filter rows where the city column equals New York. We could say data frame, and then where the city is equal to New York. And this will return another Boolean series containing true or false for where each row in the city column was equal to New York. If we index our original data frame with our Boolean series here by passing it inside of some square brackets, we'll then get all of the rows back where our Boolean value was true, or in other words, where the city was equal to New York, as we can see here. We could also add in another index to our data frame here at the end. So I'll just add in another index to select our name and city column, and then we'll just get these two columns returned. Okay, and then the final thing that I'd like to show you about conditional selection is how to select data but based on more than one condition. So far, we've looked at how to conditionally select data from our data frame, but with only a single condition. So where our age was greater than or equal to 30, and where our city was equal to New York. But what if we wanted to look at multiple conditions, such as both where our city is equal to New York, and then where our name is equal to David? Well, this is also possible. And what we could do is this. We'll wrap our first condition, so is city equal to New York, in parentheses, and then we'll add in the and symbol, open a new set of parentheses, and then in here we can actually add in a second condition. So we'll put if our name is equal to David. And then if we run this, it'll take both of these conditions into account. Something important here is that we actually have to use the and symbol and not the and keyword that we looked at before. If we try using the and keyword, it'll return an error telling us that the truth value is ambiguous. And this happens because the and keyword works for single Boolean values in Python, for example true and false, but it doesn't work directly with arrays of Boolean values like those generated by Pandas comparison operations. Okay, and now that we've covered how to conditionally select our columns, let's have a look at how to actually create and add new columns to our data frame. To demonstrate this, let's add a new column called age greater than or equal to 30, which will be a Boolean value for if that person's age is greater than or equal to 30. If it is, it'll return true, and if it's not, it'll return false. And then to do this, we can use one simple line of code. To start with, we'll access our data frame, which is just called df, and then we'll assign a new column to this, as we would do if we were going to index it, so inside of square brackets, and we'll call it age greater than or equal to 30. And as this column doesn't exist in our data frame, this will actually create a new column instead. And then we can say that this column is equal to our data frame age column, which we can access by indexing again, and then where the value is greater than or equal to 30. If we take a look at our data frame, we'll see that we've got a new column over here at the end with the name that we set, and then a Boolean series of true and false values, which if we look at one of the rows for where this value is true, the age in this case is equal to 30, so the condition is met. And then for any rows where it's false, the age is less than 30, so the condition of greater than or equal to 30 is not met. As another example, let's create a new column for the birth year, which we'll say is equal to 2024, which is the year that I'm creating this lecture, minus their age. And this, of course, doesn't account for months, but it's still a good example to demonstrate how to create new columns. Okay, and great job so far. Now that we've had a look at how to create columns, let's have a look at how to drop or remove columns from our data frames instead. This can be done very easily with the drop method, which we can call on our data frame. Inside of our parentheses, we'll need to provide two arguments. Firstly, the name of the column that we want to drop, and then next is the axis. This method defaults to have an axis of 0, which is actually our row labels. As we want to remove a column from our data frame, we'll need to set our axis to be 1, and then this way Pandas will search our columns for the provided label as opposed to our rows. If we run this, we'll get our data frame returned with the column removed, but like we've looked at before, this change doesn't apply to the original data frame, so we'll need to pass in the in-place argument here and set it to true. Or alternatively, we could also reassign this to our data frame that we covered when setting our data frame index values. And similarly, as mentioned, we can also drop rows from our data frame with this method as well. So instead of providing a column name, we could actually provide a row label or index number, and then this time, as we're working with the row or label axis, we'll need to set our axis to be 0. Or alternatively, we can remove this argument entirely as the axis defaults to 0. Okay, and that there finishes up our second lecture on data frames. Over these last two lectures, we've covered all of the most essential points and topics regarding data frames, so we're now ready to move on to some other topics, starting with grouping and sorting our data, which we'll look at in the next lecture. If you've got any questions about data frames or Pandas so far, then please feel free to leave them down in the Q&A section below, and I'll of course be happy to help you out. Thanks everyone, good job so far, and I'll see you in the next lecture.